Okay, we're diving into Chapter 1 of IBM's Principles of Operation Manual. Or maybe I should say publication. I'll leave this picture up for one more video. And if you want to read along, you can go to this link right here. Let's dive in. Chapter 1, Introduction. The architecture of a system defines its attributes as seen by the programmer. That is, the conceptual structure and functional behavior of the machine, as distinct from the organization of the data flow, the logical design, the physical design, and the performance of any particular implementation. Several dissimilar machine implementations may conform to a single architecture. When the execution of programs on different machine implementations produces the results that are defined by a single architecture, the implementations are considered to be compatible. System 370 is a product of the experience gained in developing and using several generations of compatible general-purpose systems. Looks like Word Dictate is going to be very buggy on us today. So starting with System 360 as a base, System 370 incorporates a number of significant facilities, which are described below. The first one is Dynamic Address Translation. DAT is a facility that eliminates the need to assign a program to fixed locations in real storage and thus reduces the addressing constraints on both control programs and problem programs. This provides greater freedom in program design. Dynamic address translation permits a more efficient and effective utilization of main storage. When one of the operating systems for virtual storage is used, dynamic address translation allows the use of up to 16 million bytes of virtual storage, 2 page sizes, 2K and 4K bytes, and 2 segment sizes, which is 64K and 1 million bytes, are provided, although some models offer only the 64-byte segment size, and some models offer only the 4K byte page size. Extensions to this facility include the common segment bit, the use of which increases effective size of the translation look-aside buffer, and thus improves CPU performance. And the instruction invalidate page table entry. So I want to underline that instruction for you. This instruction improves CPU performance in a demand paging environment. The next section here is titled Protection Facilities. They include a storage key, which is standard on all models. On some models, this is extended by low address protection, the use of which increases the protection of storage locations at effective address 0 through 511, which are vital to the control program. Segment protection, which is available on some models, provides a segment protection bit in the segment table entry. When the bit is 1, an attempt to store in the segment causes a protection exception to be recognized. Next, we have extended real addressing. This is an extension to dynamic address translation, and it provides the CPU with the capability of addressing up to 64 million bytes of real storage. This is accomplished by the use of bits 13 and 14 of the page table entry, which serve as the high-order bits of the page frame real address when 4K byte pages are specified. The larger address size applies to the real address provided by dynamic address translation and to the address provided by the load real address instruction. Okay, that's underlined for your viewing convenience. Next, we have channel indirect data addressing. A companion facility to dynamic address translation provides assistance in translating data addresses for I/O operations. It permits a single channel command word to control the transmission of data that spans non-contiguous areas of main storage. In the basic form, the indirect data address word contains a 64-bit address. This becomes a 31-bit address when the 31-bit IDAW facility is installed. Next is multiprocessing. Provides for the interconnection of CPUs to enhance system availability and share data and resources. It includes facilities for shared main storage, for programmed and special machine signaling between CPUs, and for the programmed reassignment of the first 4,000 bytes of real storage for each CPU. Channel set switching permits the collection of channels in a channel set to be connected to any CPU in a multiprocessing configuration. Timing facilities include a TOD clock, a clock comparator, and a CPU timer, along with an interval timer that is also available in System 360. The TOD clock provides a measure of elapsed time suitable for the indication of date and time. It has a cycle of approximately 143 years and a resolution such that the incrementing rate is compared to the instruction execution rate of the model. The clock comparator provides for an interruption when the TOD clock reaches a program-specified value. The CPU timer is a high-resolution timer that initiates an interruption upon being decremented past 0. Extended precision floating point includes addition, subtraction, multiplication of floating point numbers with a fraction of 28 hexadecimal digits. Also included are instructions for rounding from extended to long and from long to short formats. Program event recording provides program interruptions on a selective basis as an aid in program debugging. The Dual Address Space (DAS) facility provides for the support of semi-privileged programs, which are executed in the problem state, but which, when allowed by authorization controls, are also permitted to use additional capabilities previously available only through the assistance of supervisor state programs. The capabilities include 1. A PSW key mask that controls the PSW keys, which can be set by the program, and 2. A second address space called the secondary address space, together with an address space control bit in the PSW that permits the program to switch between the primary and secondary address spaces. And then number 3, a table-based linkage mechanism which permits a program with one authority to call a program with greater authority. Start IO fast queuing permits a subchannel to accept a SIOF function even when certain IO busy conditions are encountered. If accepted, the SIOF function is held pending until the required facilities are available. An SIOF function is initiated when a start IO fast release instruction is executed and other necessary conditions exist. Start IO fast queuing may be provided for one or more subchannels of a channel. The suspend and resume facility provides a means for programmed control of the progress of a channel or of channel program execution. A flag bit is provided in the channel command word, CCW, which indicates that channel program execution is to be suspended by the channel prior to executing the CCW. A new bit is added to the channel status word, which indicates that a channel program has been suspended. A control bit is provided in the channel address word, CAW, which indicates that the suspend function is permitted for the channel program. An instruction, resume IO, causes a suspend channel program to be resumed. The suspend and resume facility may be provided for one or more subchannels of a multiplexer channel. So this next section is titled General Purpose Design. System 370 is a general purpose system that can readily be tailored for a variety of applications. A commercial instruction set provides the basic processing capabilities of the system. If the floating point facility is installed with the commercial instruction set, a universal instruction set is obtained. Adding other facilities, such as the extended precision floating point facility or the conditional swapping facility, extends the processing capabilities of the system still further. System 370 has the capability of addressing a main storage of up to 64 million bytes. The System 370 Dynamic Address Translation Facility, used with appropriate programming support, can provide each user with an address space of 16 million bytes. independent of the amount of main storage. The dual address space facility extends this by providing each user with multiple address spaces. This facility and this support permits a System 370 model with limited main storage to be used for a much wider set of applications, and they make many applications with requirements for extensive storage practical and convenient. Another major aspect of the general purpose design of System 370 is the capability to attach a wide variety of I/O devices through a selector channel and two types of multiplexing channels. System 370 has a byte multiplexer channel for the attachment of unbuffered devices and of a large number of communications devices. Additionally, it offers a block multiplexer channel, which is particularly well suited for the attachment of buffered devices and high-speed cyclic devices. An individual System 370 installation is obtained by selecting the system components best suited to the applications from a wide variety of alternatives in internal performance, functional ability, and input-output. And that's the end of that section. Okay, so let me take you through a little tour of parts of the next section, and then I'm just going to skip down to the availability section. It's way more entertaining. So here we are with availability. I like that they define this right away. It is the capability of a system to accept and successfully process an individual job. Okay, so we'll go over here. System 370 permits substantial availability by 1. Allowing a large number and broad range of jobs to be processed concurrently, thus making the system readily accessible to any particular job, and 2. Limiting the effect of an error and identifying more precisely its cause, with the result that the number of jobs affected by errors is minimized and the correction of the errors facilitated. So that's interesting. Availability has sort of always existed since the 70s. In the world of cybersecurity, we talk about availability quite a bit, being part of the CIA triad. I guess I don't see much difference here. This is explicitly saying the system needs to be available to do a broad range of jobs. Literally, they said readily accessible. All right, so they say several design aspects make this possible. A program is checked for the correctness of instructions and data as the program is executed, and program errors are indicated separate from equipment errors. Such checking and reporting assists in locating failures and isolating effects. The protection facilities, in conjunction with dynamic address translation, permit the protection of the contents of storage from destruction or misuse caused by erroneous or unauthorized storing or fetching by a program. This provides increased security for the user, thus permitting applications with different security requirements to be processed concurrently with other applications. Dynamic address translation allows isolation of one application from another, still permitting them to share common resources. Also, it permits the implementation of virtual machines, which may be used in the design and testing of new versions of operating systems, along with the concurrent processing of application programs. Additionally, it provides for the concurrent operation of incompatible operating systems. Multiprocessing and channel set switching permit better use of storage and processing capabilities, more direct communication between CPUs, and duplication of resources, thus aiding in the continuation of system operation in the event of machine failures. Monitor call, program event recording, and the timing facilities permit the testing and debugging of programs without manual intervention and with little effect on the concurrent processing of other programs. Emulation is preferred under control program supervision, thus making it possible to perform emulation concurrently with other applications. On most models, error checking and correction in main storage, CPU retry, and command retry provide for circumventing intermittent equipment malfunctions, thus reducing the number of equipment failures. An enhanced Machine check handling mechanism provides model-independent fault isolation, which reduces the number of programs impacted by uncorrected errors. Additionally, it provides model-independent recording of machine status information. This leads to greater machine check handling compatibility between models and improves the capability for loading and operating a program on a different model when a system failure occurs. A small number of manual controls are required for basic system operation, permitting most operator-system interaction to take place via a unit operating as an I/O device, and thus reducing the possibility of operator errors. And so on that note, that was the end of Chapter 1. In the next video, we'll read about organization. Looks like we have 4 main sections there: main storage, CPU, I/O, and operator facilities.